diodes are ideal. Now, what can we say that if the diodes are ideal? What can we comment out the diode? So, if any positive voltage came to the anode of the diode, it will be forward bias, or the voltage difference between the nodes of the diode, if that is positive, then we can say that the forward voltage diode will be forward bias. Now, see here at the cathode, the voltage is minus 5 volt. Here the voltage is minus 5 volt, and so we can say that if any kind of voltage is there, let's suppose V0 is something 0, if no current is flowing, the V0 is 0, then we can say that this diode will be forward biased. Is it clear or not? Even if the
Yes, sir.
even if the V0 is 0, the diode will be forward biased because it's an ideal diode, no drop will be there. Now, so if the diode is forward biased, the circuit will be looked like this. This is V0. This is minus 5 volt. Now V0 sign is given as plus and minus. So whatever be the node voltage here, the whole node voltage is equal to here also. So this node voltage is minus 5 volt. Now this node voltage is 0. It is grounded. We can see that this is grounded. So V0 is minus 5 volt. We can easily see that. And if V0 is minus 5 volt, you have to measure the current. Now what can I comment about the current? Whatever current is flowing through here, the whole current is flowing through here also. Because there is no path here. There is no path here. So whatever current is flowing through this resistor, the whole current will flow in this resistor. Now someone can comment that, yeah, sir, here also it is open circuit. No circuit is given here. Now the circuit is not given, but the thing is here can be another electrical network is there. Okay, that's why this is the minus 5 volt. Okay, that's why many kind of work medical some kind of electrical network is there. That's why the voltage is minus 5 volt there. So we can say that the current will be flow in this direction itself, because the V0 is minus 5 volt. Okay, so what is the current? So what is the magnitude? First of all, what is the magnitude of current? So current magnitude will be I equal to V by R. Now V equal to here V0 and R equal to R1. Now V is what do you have to calculate? What is V? Just a second.
minus 5.
So yeah, minus 5 volt, and R is 1 kilo ohm. So 1 milliampere will be magnitude, and the sign is minus. So in this direction, the 5. So if we consider this direction, so minus 5 ampere will current will flow, and if you consider this direction, 1 ampere current will flow. So I have mentioned the direction is in this way. So the current will be 5 ampere. Sorry, it will be 5 milliampere. Okay, so 5 milliampere current will flow here, and the V0 will be minus 5 volt. Is there any doubt?
No, sir.
Okay. So in the same way, we can solve the second question itself. It's already given. I have already explained this question in the first question itself. Here in this node, the negative voltage is coming. So is this diode will be on or off?
On.
How this will be on?
Off.
Off. It will be on. So if the diode is like this, if you give a positive voltage here or a negative voltage here, okay, then the diode will be on. Because we have to make the potential. We have to forward bias it. How can we forward bias it? We have to make the anode part positive potential. We have to make the cathode part negative potential. Either of these create a forward bias in this diode itself. So here we can see that in the anode itself there is minus 5 volt. So if there is a minus 5 volt in the first node, then we can say that this diode will be in reverse bias. So this wire will be open circuit, so no current will flow through here. And if no current is flow through here, no current will flow through R also. If zero current is flow through R, then the V0 will be 0 volt. So obviously the ID diode current and the V0 both will be 0 volt. If some amount of current will flow, in the ideal case, some leakage current will flow. You know, all guys know. Then we can, in the ideal case, in the practical case, we will get some voltage V naught here. But the thing is, in here we have assumed that diode is ideal, so no current will flow. So the this ID will be 0 and the V naught will be 0. Okay. So the third question, I don't think is there any doubt in third question? First of all, say how many guys
Yes, sir.
how many guys have doubts in the first question?
Yes, sir, I have.
Okay. So what is the doubt?
Sir, if the node voltage is less than -5 volt, then it will be a forward bias or still remain a reverse bias.
Okay. Now I will give you some example. After that, we will see me the answer. Okay. See, some diode is there. Okay. So this is anode. This is cathode. You know. Okay. This is the P part. This is the N part. Now, if we make this part grounded, okay, and if we giving a voltage here, this part, some voltage V, we are giving, okay, it's connected to a voltage V. Now, if we increase the voltage V, let's suppose we are increasing the voltage from -2 volt. Okay. Now see, at voltage at V equal to -2 volt, what will be the current flowing through the circuit? Hello.
Sorry, sir.
At V equal to -2 volt, what will be the current flowing through the circuit?
0.
0. Why 0?
So, voltage is positive or negative?
Voltage is negative, -2 volt. Actually, V equal to -2 volt. Why this is 0?
So, current flow in the another direction, because at that point, at the cathode side, the voltage is 0 because it's earth.
Hello, Rahul, you are not audible, Rahul. Hello.
Hello, sir.
Yeah,
I'm
you are
audible.
audible now. Say.
Sir, I am just saying that the cathode part is earth. So,
Yeah, it's grounded.
yes, sir. So there will be 0 voltage at the cathode side
Exactly.
and -2 at the anode side.
Yes.
So current is flow, never flow.
Current will not flow.
Yeah.
So what is the, like, a diode is a switch, right? So to on this, so it is like a switch. A diode can be modeled as a switch. Like, see, this is a diode, and this can be modeled as a switch. So this switch will be on. This switch will be closed when the potential here will be positive, like plus minus. If this is any positive voltage, like whatever for ideal case, whatever the minimum voltage you can assume. Let's suppose it's 0.00001 volt. Okay, this diode will be closed. This will be a closed short circuit. But if there is a negative voltage, if it is 0 or negative, then this diode will be open circuited. It will be modeled as this one, right? It is clear now?
Okay, sir.
Okay. So see, now if here is a -5 volt, now what is the voltage here? -5 volt in this.
Yes, sir.
In this anode part. Okay. Now see, if there is a -5 volt here, this diode will be turned on or off?
Off.
Off. If the diode is off, then this path will be open circuit or not?
Okay.
Open circuit. So if there is open circuit, the current will flow through the circuit or not?
No.
Current will not flow. If current is not flow, is there any voltage drop through the resistance? Across the resistance, there will be any voltage drop?
No, sir.
No voltage drop. Then what will be a V naught? If there is a no, like, if what do you call mathematically no? No is 0, right?
Yes, sir.
Yeah. So V0 will be 0, right?
Yes, sir.
Okay. So understood, everyone? Your doubt is clear, Rahul?
Yes, sir. Thank you.
Okay. Now see, there is a case like many guys think that if there is a negative voltage here, like in the cathode side itself, sorry, anode side itself, then the diode will be not turned on. Now I am giving you a case. Okay. After that, we will solve the questions. Now let's see. There is a diode here. Now I am making this terminal as minus 5 volt. Now I am making this terminal as minus 10 volt. Now say this diode will be turned on or no? Oh, turned on or turned off?
It
This
will
is
be
my doubt, sir.
It's messy sound. Can you please repeat?
it will be on.
It will be on.
It's on.
Yeah, it will be on. Yeah, everyone is saying that it will be on because the voltage across the resistance is across this drop diode is positive because minus 5 plus minus of minus 10. This will be minus 5 plus 10. This is 5 volt. So the voltage across the 5 volt, the voltage across the diode is 5 volt. Then you can say that this diode will be turned on. Okay, this kind of conceptual thing you have to take care of. Okay. So just give me a second. Okay. Now this question. So here the resistance are mentioned as 1 kilo ohm, right? 1 kilo, 1 kilo. So we can easily say now from this example itself, it is the ideal diode. So it will be if there is a positive voltage here, intuitively we can say that something positive voltage will come here. Some positive voltage, we don't know what is the voltage, but some positive voltage will come here. This some positive voltage and this negative voltage will make the overall voltage positive through anode to cathode of this diode. So this diode will be short circuited. Now there is a direct path from resistance, these two resistance and these two potentials, 5 volt and minus 5 volt. So if this and these two resistance are in series, okay. So what is the equivalent resistance through this path? R1 plus R1,
2.
that is 2 R1. That is 2 kilo ampere. So 2 kilo ohms, right? Everyone is understanding my concept?
Yes.
Is there any doubt? Hello?
No doubt, still.
Okay, okay. Now, what is the current here? Current will be V by R, right? We have to find the current ID. So, what is the equivalent V here? 5 of minus 5. So, 5 minus of minus 5 by 2 kilo ohm. So, 10 volt by 2 kilo ohm. Okay. So, 5 milliampere will be there. Okay. Is there any doubt? Okay, I'm moving to the fourth question. See, here also all diodes are ideal. Now see, if the all diodes are ideal and some positive voltage is there, so for this, if there is this is ideal voltage, this will be short circuit. So ideal diode, this will be short circuited, and this ideal will also be short circuited. Okay. Now, if I make some questions here, if these diodes are not ideal, then what will happen? Here we can easily say that here two diodes are in series. The both diodes are in ideal case. So and some positive voltage is there in the anode. So both these diodes will be forward bias, and this whole 15 volt potential will come to this node 15 volt. Okay. Now these two are in series. We can say the current I equal to 15 by R1 plus R2. Okay, so we can find the current here and we can find the voltage across here. Okay, that is an easy question. It is like this question also. Just I have made a made a node here. We know just this thing. Okay, now see, if I say that we have a voltage drop here 2.5 volt, 2.5 volt, like we can say that ideally the diode is modeled as, the diode is not ideal diode, and it is modeled as this diode plus a voltage source 2.5 volt. Let's suppose the cutting voltage of this diode is 2.5 volt. Then how can you proceed? What voltage will come to this node?
We need 2.5 or
10,
greater
10,
than 2.5.
20.
What?
No, drop. 50, 10, 10.
Can you please say louder? I can't get your answer.
There will be potential drop of 5 volt. So the voltage at the node will be 10 volt.
Exactly. Everyone got this point?
Yes, sir.
Okay. Because there is a two diodes, so both diodes will drop 2.5 volts. So overall drop will be 5 volt. So 15 volt is there. So 10 volt will come to this node. Now we can analyze the question.
Sir, how did we tell that there is a drop of 2.5 volts across the diodes?
Because the diode is non-ideal. Well, in the class itself, the professors told you, right? A diode is modeled as a practical diode is modeled as a diode and a voltage source in series. You can make the voltage source here or here, this side or this side. It doesn't matter. Okay, this is the black box, and this diode you will got by the shop. Okay, this is the black box. Now see, and someone may question us why this voltage drop is there. Actually, it is a device that is a part of device, and that is actually out of our scope. But when you make the device, this is the drawback of the device. You can't make an ideal device. Okay, there is nothing ideal in the earth itself. Okay, so if you make the device, you have to pay. If you want some like advantages, you have to pay some price. Okay, and this is the price you pay. Okay, so in this case, generally in silicon diode, this cutting voltage is generally 0.7 volt. Okay, for germanium it is 0.3 volt. You know this kind of information. But I have mentioned here, this is the arbitrarily I have mentioned this voltage is internal voltages.
Okay, sir.
Sir, if there is a polarity is not given, then what polarity we should make for voltage?
What?
If the voltage is not given there, then what polarity we should make?
You always you always to assume the polarity against the voltage. Whatever with the voltage which are causing the forward bias of the diode. Okay, you have to take the polarity against that voltage. Understood, right? If there is a reverse bias, if there is reverse bias is caused, then there is no this kind of questions are there, because there is reverse bias. The our resistance provided by this diode is infinite, so that will be open circuited. So whatever be the voltage at both the points, that will be the voltage in like, see, if I say that, you guys will not understand. See, now some external circuit is there. Okay, now some circuit is connected to a diode like this. Okay, now some voltage will come here, and it will cause a forward bias here. Like we are assuming this is the ground node, and this is some positive potential. Let's say 1 volt, and this is the ideal diode. Okay, this positive potential will cause a forward bias junction here. Okay, and if the diode is forward bias, it will be modeled as a short circuited path, right? Okay, for ideal case. But for the practical case, what we will do? We will replace this diode by a voltage source, which is the internal voltage that will be mentioned in the question. Like for the silicon, it will be 0.7 volt. Now this is the voltage that is coming, and this voltage is working against this voltage, 1 volt. Okay, so you have to choose the polarity like that. Now the second case, if the diode is reverse biased, that is your reverse bias. So now no current will pass through here, right? So then we'll simply open circuit this path and we can say that whatever be the previously voltage is there, this 1 volt, now also there will be 1 volt across this region. Okay, is there still any doubt? Hello?
No, sir, from my side.
If is there any, if there is a doubt, you can okay, no doubt, you can say me. Okay, you can stop at any time. Okay, this has to be an interactive section. Okay, now see this question. Now can you like without touching a pen and paper, can you intuitively solve this question? I have already explained this question just in the last question itself.
This will be forward bias.
Okay, how can you say that this will be forward biased?
Because higher potential will be at P.
Okay, so you are saying that this is the P node, so there will be a higher potential here, right?
Yes.
Okay, very good. Then how can you, now after that, how can you model this circuit?
We will make the voltage which will be opposite of that. Then we can write V1 minus that voltage upon R1.
Exactly, very good. Now this is the circuit is there. Now we have to make the opposite of this. Like, so this is the plus minus here. Now we have, for opposite, this will be plus minus, right? This is 3.7 volt. This is 0.7 volt. It is given in the question. Okay, and this is the R. Okay, R1. Sorry. Now current will flow from which direction to which direction? Let's say we are taking this node is A, this node is B. Current will flow from which node to which node?
A to B, higher to lower.
Exactly, A to B. So what is the voltage drop across A to B?
3.
3 volt, exactly, 3 volt. So what will be the current? 3 by R.
It will be 2 milliampere.
Exactly, it will be 2 milliampere. So that's how you can intuitively solve this question. Now this question. These kind of questions are asked in GATE itself. Now see, you will solve without touching pen and paper. You will solve this question. This question is asked in previously in GATE exam. You all guys know about GATE exam, right?
Yes.
Yeah. This question is asked in GATE exam itself. Okay. Now see. Acha, now here the answer is given. Now, if you, let's suppose you don't know the answer, how can you approach this question?
We will first write the opposing voltage, then check which will get forward bias first.
Okay.
And other will get reverse bias because one will get forward bias. So that will be the answer.
Exactly. Now I will explain what she said. Okay. First step we have to model these diodes as a voltage source, right? And the voltage source polarity will be opposite to the input voltage which is given, not the input voltage. Whatever be the voltage which are causing the forward bias, we have to model that voltage opposite to that, right? Now there are 3 paths. Looking first. Now here is a voltage source. The voltage source is given as 5 volt. Now whatever be the polarity, now say anyone say that what is the polarity here?
Left
Plus on the left
positive.
and minus on the right.
Okay, very good. Now diode D1 is given as 0.5 volt. It is 0.6 volt. It is 0.7 volt. And this is resistance R1. Now which one will be forward biased?
0.5 volt one.
Why?
Because it has the least voltage drop. So it will activate first, and if it activates, then both of the terminals will set to 0.5 volt and other will not get activated.
Exactly. Okay. Now I will explain the question in other way. Okay. Let's say this 0.7 volt got forward biased. We don't know which path got forward biased. Let's say this path got forward biased. Okay. Now if this path got forward biased, 0.7 volt will come here we can say that there is, let's suppose this is 0 and this will be 0.74. Okay, this is not 0. I'm arbitrarily assuming because we have to show the voltage drop here 0.74. Okay, that's why I'm making this part 0, this part is 0.74. Okay, now if this is 0.7 volt, this path will be get turned on, this path will be get turned on. Okay, but and also in parallel we are saying that if this is 0.7 volt, this will provide 0.6 volt, this will provide 0.5 volt. Now in parallel the voltages are different. Now it is invalid rule. It is not validating KVL and KCL, the basic rules of electrical engineering. Okay, we assume this diode is forward bias, this D3 is forward bias. Now the D3, when we are assuming D3 is forward bias, we are also saying that in parallel the voltages are different. Is it possible? In parallel voltages can be different? No. In parallel voltage can't be different. In series current can't be different. If there is a series path, through all the elements same current will flow, and if it's a parallel path, through all the elements the voltage will be same. Okay, now so this our assumption is wrong, this assumption is wrong, so we can directly say that the D3 do not get turned on. Okay, so this is cancelled. Now let's say this D2 get turned on. Now if D2 gets turned on, the same scenario happens again. If D2 is saying that the voltage drop between this node and this node is 0.6 volt, and D1 saying that the voltage difference is 0.5 volt. This will can't be happen also. Okay, now this assumption is also wrong. This assumption is also wrong. It can't be possible. Now only thing left is 0.5 volt. Okay, now if we assume 0.6 volt, one thing I have left, if we assume 0.6 volt, now D3 will automatically cut off, because if there is a 0.6 volt here, this D3 will not turn on, it will be reverse biased, right? Everyone got this point? If D3 is D2 is 0.6 volt, then D3 will be cut in the reverse bias. Okay, now the last assumption we have, the last assumption left is 0.5 volt. If 0.5 volt is there, now we can say that this path is got cancelled, this path is got cancelled because D2 will be reverse bias, D3 will be reverse bias. Only path left is this. Okay, so our voltage drop, the voltage drop between this and this will be this point and this point and this point will be 0.5 volt. Okay, 0.5 volt. Now what is asked in the question? Find which of the diodes get turned on. Obviously D1 get turns on. Now if I say that, what is the potential here? This is V out. If I say that, what is the potential here? What will be the answer?
4.5. 4.5.
Exactly. 4.5. Everyone got this answer?
Yes, sir.
If there is any doubt for any students, say freely. Okay, I have not any professor. Okay, I'm like just your brother. You can say me. I will I'll make you learn these things. If these kind of basic things are not, you will not get. Okay, you can't understand the major concepts. Okay. Now if I say that in this question 1000 diodes are in parallel, okay, and the lowest minimum possible voltage drop through the diode across the diode is 0.3 volt, and all the other 999 diodes having the higher cutting voltage, then we can easily say that only that part will get turned on. Okay.
Yes, sir, understood.
Okay. Now next question. Okay, so what is the symbol of this?
Zener diode.
Zener diode, exactly. Okay, and can anyone show me what is the specialty of Zener diode?
Regulates the voltage.
It regulates the voltage. It's it's a very posh answer. Like in a layman, if anyone know that
in
what is
reverse bias, it regulates the voltage.
If I don't know what is voltage regulation, what can you say? If I don't know what is voltage regulation,
the VI characteristic of a Zener diode in the reverse polarity is that the current can be very huge and voltage increases slightly. So basically, it stays constant. We can say that in that manner.
So basically, he's trying to say that if a zener diode is mainly the zener diode is kept in anti-parallel with the voltage source. Okay, like we do not get the forward bias. We do not use the zener diode as forward bias. In forward bias, zener diode is as good as the simple diode itself. Okay, we basically use the zener diode in reverse bias. Okay, in reverse bias, if we like for all the diodes, if we kind of diodes in reverse bias, if we keep increasing the reverse bias voltage, at certain point there will be a the diode will be like burst. Okay, there's a terms, I am not using the terms. Okay, the diode will be burst. Okay, so we can't use the simple diode for all the cases. But if we use the zener diode, it will stop the voltage. Okay, at some point, and we'll get that stopped voltage, whatever be the voltage stopped at that point. Okay, we get that voltage at the output. Okay, now after doing this question, the whole doubt will be clear. Okay, now see, and what that voltage, at that voltage the voltage gets stopped increasing. That is the reverse bias voltage of the zener diode. Now this reverse bias voltage is given in this question is 2.5 volt, 2.4 volt, right? Now if 2.4 volt is given, we can easily say that this is in reverse bias, and we can model it as a 2.4 volt source here, plus minus 2. Right? Now if 2.4 volt is there, what will be the voltage? What is given?
Across R.
Vout is asked. Okay. What is the voltage across this R? Forget about Vout. What is
V1
the,
minus 2.4.
what? Say again.
V1 minus 2.4.
V1 minus 2.5. Can you please say the answer? What is the answer across this resistance? The Vout is 2.54 volt. We can easily say that. Okay.
5
Because
minus 2.4, that is
2.6 volts.
2.6.
3.6. Yes, 2.6.
Now these kind of things are very intuitive, right? Okay, if you get this kind of circuits, you will not touch pen and paper. You will solve by your own. Okay. Now what will be the approach of this eighth question? This is a simple question. Okay. What is the approach? I want to know the approach. Like if you don't have pen and paper.
Ohm's law.
Okay. So explain. If you say one word, most of us will not get the answer. Okay. Explain the question.
Actually, we can think
R equals to V
the
by I.
characteristic as a piecewise linear function. Then piecewise linear means it will be linear in that reverse bias zone. And if linearity is taken as an approximation, then I can use the Ohm's law.
Okay. So basically, he is trying to say that some diode is there. Okay, and we are putting a voltage minus V here. Okay, so instead of putting this way, I can easily say that. Sorry, this is. Can say that this kind of voltage is given, right? This is 5 volt. 5 volt is considered as this way, here to here. If this is minus 5 volt, this is equivalent to this one. Everyone got this?
Yes, sir.
So if some if this is connected here, and let's say we don't know what is here. What is here? We don't know there is a diode or something. Something is there, and we have given a black box is there, and it is given this current will flowing through here. So current through a diode in this direction is minus 0.001, right? So we can say that in this direction 0.001 ampere is currently flowing.
Yes, sir.
Now,
Yes.
now for a layman, okay, he don't know this kind of things. He only know current and voltage Ohm's law. Okay, the first guy told it. I don't know the name. The first guy told this thing. Okay. Now we have applied some voltage. You are getting some current. How can we model this? This black box. What will be this black box?
Resistor.
Resistance.
Simple resistance. We are applying some voltage. We are getting some current. And what will be the resistance?
V by R.
V upon I.
V upon
Delta
I.
V upon I.
Yeah. R equal to V upon I. Ohm's law says that V equal to I R. V upon I. So V is 5.
This will be
5
5.
0.001. Okay, this is 5000 ohms or 5 kilo ohms. Okay. Now, is there any doubt in this question?
No, sir.
Okay. So next question: if the diode is forward biased with a voltage drop of 0.7 volt and is connected in series with the 100 ohm resistor, what will be the voltage across this resistor 5? So how can we? It's again a simple question. Okay, it's not a diode based question. It's simple basic electrical question. Okay. So voltage drop is 0.7 volt. Okay, and source is given as 5 volt. Now, some 5 minutes ago, I have told you that we can we can connect the we can model the voltage model the diode as a like negative effect of the input source. Okay, where
Opposing voltage.
opposing voltage. Okay, so 5 minus 0.7 is 4.3. I think no need to solve this question, right? Everyone got this?
Yes, sir.
Okay. Now this thing, how can we calculate this? Now it's look like a very big circuit. Okay. Now I have also explained this kind of
D1
thing.
and D2 are not separate. Both are D1.
Okay. Both are both are D. Oh, sorry. This is a mistake. This will be D2. Okay. Now 0.7 volt and 0.8 volt. Voltage polarity will be plus minus 0.7 plus minus 0.8. Okay. So what will be the equivalent voltage here?
In the left side there will be negative and right side there will be positive, and the
No,
total
I'm saying that what
voltage
is the
will be
equivalent voltage here?
2 volt.
2.
2 volt. How? Who can explain why this is 2 volt?
Sir,
Because
the
the
VD1 and VD2
Through the
terminals
first
will
diode,
have
it will
negative of 1.5 volts.
Exactly. So the whole, so from here to here, total 1.5 volt is dropped because 0.7 plus 0.8, and this voltage are in series. So in series, and according to the polarities, the voltage will be added. So 0.7 plus 0.8 increase 1.5. So 3.5 minus 1.5 will be 2. So there will be voltage drop of 2. Okay. Now R is given. So R is 2 kilo ohms. Now what will be current through here? I.
I is equals to V upon R. 2
2
by
by
2 kilo.
2 kilo ohms, that is 2 milliampere.
2 by 2 kilo.
1 milliampere.
Now only one path is there.
Sir, 1 milliampere.
Sorry, 1 milliampere. 1 milliampere. Okay. So only one path is there. Okay. So I just now told that in series the currents will not be different. Okay. In series the current has to be same. So 1 ampere current will flow. Okay. Now this kind of questions. Now we will solve this question by our intuition, not by solving like numerically and rigorous analysis. Okay, first we will solve by our intuition. Okay, now see, this V is varying from minus 5 volt to plus 5 volt, right?
Yes.
Let's say we are standing at 0 volt. Okay, so this is vary from minus 5 to 5, right? Minus 5 to 5 volt, right? If the voltage waveform is there, we can say that this kind of voltage waveform is there. This is plus 5, this is minus 5, or maybe this kind of things. Whatever, we don't know what is this. Okay, but this kind of waveforms is there. Is there any sinusoidal mentioned? No, sinusoidal is not mentioned. Some kind of waveform is like there. Okay, let's say we are standing at V1 equal to 0 volt. So there is no input, right? So if there is no input, this whole path is shorted. 0 volt means short circuit path. You all get it. If there is short circuit path, so is there any voltage across D1 and D2?
No.
No. So if there is no voltage across D1 and D2, can we get any voltage across V out?
No.
So if V in equal to 0, V out equal to 0, we find that. Okay?
Yes.
So if V at V equal to 0, V out will be 0, but all the options are saying that if V equal to 0, V out will be 0. Except this two. Okay? No, this two is also saying that. also. Okay. Now, what will be our next step? How can we solve this? How can we? What will be our next step? What will be our next integer process?
First, I'll take the positive cycle,
Okay.
then negative cycle, and then
Okay. Let's say we are taking the positive cycle first. Okay. So now this is the this is
0 to 5.
plus 5. Let's say we are standing at plus 5 because the diodes are ideal. Okay. So if no, diodes are not ideal. 0.7 volt. Okay. So this is 0.7 volt. Let's say we are standing at plus 5 volt. Okay. Now what will be there? Now if there is plus 5 volt is there, some voltage drop will be there. Okay, here some voltage drop will be there. Now if some voltage is dropped there itself, okay, now we can say that these diode will be reverse biased, right?
Yes, sir.
Yes, sir.
But if there is a positive voltage, these diode will be forward biased.
Yes, sir.
Okay, so in plus 5 volt, if this diode is forward biased, what will be the voltage across this one? This we can model as
Positive, then negative.
0.7, right? Right?
Yes, sir.
Everyone got? So at V1 equal to V1 equal to 5 volt, the V out will be 0.7 volt, right?
Yes, sir.
Now now first two options are only saying this, right? No, not first two.
Only
Not
first.
Only first option is saying that. Only first option is saying that only this if V1 equal to 5 volt, V out will be 0.7. So within 30 seconds we can give the answer. Okay, but we will solve the whole question. Okay. Now same
It is
thing.
written as 1.4 volt in the V in.
Yeah, we'll explain. Don't worry. We are at the 5. If this is 1.4 volt, at this point there will be 5 volt, right? So at 5 volt also there we are getting 0.7. We are getting 0.7 volt, right? Here will be 5 volt. Here will be 5 volt, right? So only this option is getting. Okay, you understood?
Yes, sir.
Yes, sir. Yes, sir.
So in the same way, if we give minus 5 volt here, okay, minus 5 volt here, so we'll get the voltage here plus minus 0.7, right? Then that V out will be minus 0.7 volt.
Yes, sir.
So also here we can say that this is minus 0.7 volt. Okay. Now what will be the thing in between 0 to 0.5 and 0 to minus 5? We have to analyze this. We got the answer. Okay, but now our thing is we have to analyze these things. Okay. So let's say we are increasing this voltage. We are let's say this voltage is varying sinusoidally. Slowly we are increasing. Okay. Now say this is 0. We are increasing. At 0.7 volt, this is eventually for a reverse bias. It will not came in the picture, but this diode will came in the picture. At 0.7 volt is just about to forward bias, right? But there is a drop here. It will not forward bias at the point of 0.7 volt. After 0.7 volt, okay, this like let's say 0.75 volt, this diode will get forward biased and the voltage will keep at 0.7 volt. You got? You always got?
Yes, sir.
If anyone not getting this, please say me. Okay. Only 1 or 2 are answering that they got. What about the others? Is everyone getting? Yes. You guys are not compatible with turning your mic on. Okay, so at 0.7 volt, okay, well the input voltage is crossing just 0.7 volt, now this diode will get forward biased. Okay, some voltage drop will be there. That's why we are not assuming at 0.7 volt itself. Okay, so just after 0.7 volt, this diode will get turned on, and this voltage will be
Forward.
forward bias. But in between 0 to 0.7 volt, 0.7 volt, no diode is forward bias, right?
Yes, sir. Yes, sir.
So what will happen in between 0 to 0.5 0 to 0.5 volt?
The current will flow from R2 resistor.
R1 and R2. Okay.
Yes, sir.
So Vout will be R2 by R1 plus R2, sorry, equal to R2 by R1
Into
plus
V1.
into V1, right?
Yes, sir.
Now we can say that Y equal to M into X here, right? This is Vout is Y and Vin equal to X. Something slope is there, M slope is there, Y equal to MX, right?
Yes.
So this Vout will vary linearly with the input voltage V1, right? So we can say that this line, this linearly varying voltage slope, if we ask that what will be the slope of this linearly varying line here, you can easily say that the slope of this will be R2 by R1 plus R2. Got it?
Yes, sir.
Okay. So at the same thing, it's the same analysis we can do that at the same analysis we can do in the negative part also. From between 0 to 0.7 volt, we can say that none of the diode will get turned on. Okay. In between 0 to 0. No. I have done a mistake here. Can anyone point out that what mistake I have done here? Can anyone point it out?
Where, sir?
I have done some mistake here. Okay. During the analysis part, I have done some mistake. Can anyone point it out?
Where?
Our intuition part is right, but while in analysis the circuit, we have done some mistake.
You wrote that 0.7 in the x-axis. That one.
Yeah, that is okay.
I saw it earlier, but I thought you didn't wrote it, so it's okay.
Yeah. That is the thing. We are analyzing from 0 to 0.7 volt, but from 0 to 0.7 volt, that this 0 to 0.7 volt thing will be divided by both in R1 and R2, right? So we is 0.7 volt is divided in both R1 and R2, and both R1 and R2 are on kilo ohm. So voltage will divide by equally, right? So if 0.7 volt is there, 0.7 volt, 0.35 volt is drop across this resistance R1. This resistance R1, and 0.35 drop will be voltage will be dropped by this resistance R2. Okay, so our output resistance will not be 0.7 volt. Output voltage will not be 0.7 volt. Okay, I will explain the thing. Our intuition part is
That's what you told, right? R2 upon R1 plus R2 into V in. That is the value of V out, right?
That is the slope part, but while doing the calculation, we have done the mistake, right? Okay, now we will do the
Basically, the
calculations.
slope will be half here because R1 and R2 are same.
Yeah, slope is half here. Okay, but in the generalized case, R2 by R1 plus R2. Okay, now see. So still now we know that when this voltage will be 0.7 volt, this node voltage will be 0.7 volt, this diode will get turned on, and this diode will keep the voltage at 0.7 volt. This diode will not allow to increase the voltage above 0.7 volt, right? This was our intention. And in the negative part itself, the same thing will happen. This diode will not allow the voltage to go below 0.7 volt. Below 0.7 volt, right?
Yes, sir.
Okay. Now what will be, so after 0.7 volt, below 0.7 volt, we'll know that. But in between, you have to analyze. But the thing is, to get this diode, this D1, D2 turned on, we have to make this voltage will be 0.7 volt. Okay. Now, when this voltage will be 0.7 volt, so we can say that V out equal to R2 by R1 plus R2. Let me analyze into V1, and this is equal to 0.7 volt, right?
Yes, sir.
Now V1 equal to, say this is 1 by 2, R2 by R1 plus R2. Okay, this will move here. It will be 2 into 0.7 volt, right?
Yes, sir.
So this will be 1.4 volt. So we can say that at V1 equal to 1.4 volt, the V out will be 0.7 volt. But if we move further, let's say we are using let's say we are providing 1.5 volt. Okay. Now this is 1.5 volt. This diode is anyway reverse biased. Okay. And this diode will provide 0.7 volt here. So V out will be clipped at 0.7 volt itself. It will not go further. But if we say that what is the voltage drop across here, plus minus here, let's say it is something VR1. Okay, then VR1 will change at 1.5 and V equal to 1.5 volt. VR1 will be what? VR1 will be what?
0.8.
0.8, exactly. 1.5 minus 0.7 will be 0.8 volt. Everyone got this?
Yes, sir.
Yes, sir.
So the same thing will repeat at the negative half itself, and the values will not change. Only the values will be negative, because this is a completely symmetric circuit, right?
Yes, sir.
So everyone got the analysis part and also the intuition part.
So please explain how you got V1 equal to 1.4.
Okay. Now see, if this diode, we don't know anything. These kind of things we don't know. Okay. Who asked this question?
So me.
Okay. Swastika, right?
Yes, sir.
Okay. See, Swastika. So when if D2 is forward biased, what is the voltage across D2?
It is 0.7 volt.
0.7 volt. If D2 voltage across D2 is 0.7 volt, what will be V out?
V out will be 0.7.
Okay. Now V out equal to 0.7 volt. Now what is the relation between V out and V in?
So can you repeat your question?
Can you what is the relation between V out and V in this range? It is simply a voltage divider, right? R1 and R2.
Yes, sir.
So at voltage divider, what will be V out? R2 by R1
R1 plus R2
Plus R2
into
into
V
V1.
V1.
into V1. So what is the value of R2 and R1?
Both
One.
are
R2
1 by 1 plus 1 into V1.
Yes, sir.
V1 equals to 0.2.
So V1 into 1 by 2 equal to 0.7 and V1 equal to 0.7
1.4.
into 2 equal to 1.
Yes, sir. Got it.
Got it? And then
Yes.
in the negative half itself, this thing will repeat itself with a negative sign. Okay?
Yes, sir.
So till 0 to 1.4 volt, we can say that there is a linearly increasing V out with V in, and the slope will be R2. Here it R2 by R1 plus R2. Here it is half. Here it is half. Okay, and this is also half. Okay, and from 0 to minus 1.4 volt, the V out will linearly increase, and at minus 1.4 volt, the V out will be clipped at minus 0.7 volt. Okay, do you know what is the name of the circuit?
Clipping, sir.
It's a clipper. Okay, it's a both level clipper actually. Okay, so everyone got the solution here.
Sir, can you explain the part like if we change it to 1.5, why are we subtracting 0.7? Won't the whole thing change? Won't V out change and everything will change? Or
Okay. So if anyone want to take any screenshot here, you can take a screenshot. So to explain this question, we have to remove this. Like, there is a lot of mess here, right?
No, sir. Like only the last part. You said if we change the V1 instead of 1.4, if we make it 1.5, then the voltage across R1 will be 1.5 minus 0.7, which will be 0.8.
Okay.
Won't all the values change? Why only is why are we subtracting 0.7 directly?
Mhm. So you're asking that the V out is not changing, but why VR1 is changing after 1.4 volt, right?
Yes, sir.
Okay. Now if V1 is 1.4 volt, we are standing at 1.4 volt. 1.4 volt. The voltage across D1 is D2 is 0.7 volt, right?
Yes, sir.
Now it is 0.7 volt. We know. So this node potential is 0.7 volt, right?
Yes, sir.
Okay. Now see, we are increasing a bit here. Let's say we are making 1.5 volt. If making this making this 1.5 volt make any change voltage across here?
No, sir. The diode will be same.
The diode will be forward bias and will keep the voltage as 0.7 volt.
0.7.
But the thing is here uh, across R1, this potential is 1.5 volt. This just give me a minute. Sorry guys, okay. Hello, sorry guys for this inconvenience. Am I audible?
Yes, sir. Yes, sir.
Okay. So see, so if we while making 1.5 volt, this voltage is not disturbed, but this node potential is disturbed to 1.5 volt, right?
Yes, sir. That was my doubt.
Now across the R1, one side is 1.5 volt, other point is 0.7 volt. So what will the voltage across R1?
Okay, sir. 1.5 minus 0.7.
Got it?
Okay, sir.
So even after if you make it 2.5 volt, let's say we are making it 2.5 volt. What will the voltage across R1?
1.8.
1.8 volt, exactly. You got this, okay?
Yes, sir. Thank you.
Now next question. So how do you believe my approach here? Same thing. The same thing is given. Now you guys solve it and first solve it intuitively without solving any without touching pen and paper. What will be our intuitive approach?
First we'll make voltages.
Okay.
Then we'll check for positive and then negative.
Okay. See, so we stand at 0. We'll increase the voltage here at V1. Now if we increase the voltage here, okay, if we make so this voltage also 0.7 volt is there. So till 0.7 volt, both this, so this will anyway, this is positive, this will anyway gone. This path will gone. Only one path is left here. Okay. So till 0.7 volt, any current will flow from the circuit.
No, sir.
Can you repeat, sir?
No, because till 0.7 volt, this is 0.7 volt, and no, if this is 0 volt, no current is flowing here. So this voltage is anyway 0. If we making it 0.1 volt, this voltage is still not enough to make this diode forward bias. So this story will continue till this voltage is 0.7 volt. So just after crossing 0.7 volt, that voltage drop across this D1 will be forward biased. Okay, and whatever voltage be here, it will be directed by some amount. And what will be the amount?
What?
So after crossing 0.5 volt, what will the, my question is, after crossing 0.5 volt, what will be V out here?
15 minus 0.7.
15 minus 0.7 volt. Exactly. Okay. So just after crossing 0.7 volt. No. After, why 15 minus? Okay, just after crossing, let's say we are making it V in equal to 1 volt. So what will be V out?
0.3.
Exactly.
0.3.
Sir, so it will start just after 0.7, it will be 0.7 minus 0.7, it will be 0. And after that, it will slowly increase. And after 1.4, no, it will keep on increasing.
Keep on increasing. Exactly. And after crossing 0.7 volt, what will be the relation between V out and V in?
Linear.
Not linear. I'm saying exact. Like, yeah, it is a linear expression. I'm saying exact. What is the expression in terms of V out and V in?
V1 minus 0.7.
V1 minus
0.7.
0.7 volt. Yes.
So C option.
So option C will be there. Yes.
Yes.
So here intuitively you can see that till 0.7 to minus 0.7 to 0.7 volt, no current will flow. If no current will flow, V out will be 0. Okay. So if V out is 0, so the characteristic will look like this. After 0.7 volt, the V out will be increasing linearly. Okay. And can you say what will be the slope here?
1.
1. Exactly. Why? Like not asking other guys. Can you say why this slope will be 1?
Yes, sir. Because through the equation of y barabar mx plus c, we can clearly find.
Yeah. So this is equal to y equal to mx plus c. So m here, y equal to v out, m equal to 1, x equal to v in, and c equal to minus 0.7. That's all. Okay. That's all.
Sir,
what?
Sir, I have a doubt.
Okay. So,
Sir, this 0.7 volt we can use, or this is just a hindrance provided by the diode?
it's I told you in the beginning of the lecture itself, you are making some device to get some advantages, but you have to pay some price. There is no free meal. Okay. So if you getting some advantages, you have to pay some prices. So this is the price you pay.
Okay,
you want a
so
switch. You are using diode in a circuit because you want a switching action. Okay. After some voltage, you want to switch it on. After below some voltage, you have to switch it off. Okay. And it is acting as an automatic switch, only controlled by the voltage, input voltage itself. But the thing is, if you want this advantage in a circuit, you have to pay some prices. It will not give you free service. The service cost is minus 0.7 volt.
Okay, sir.
You got the answer?
Yes, sir. And one more doubt regarding Zener diode, can I ask?
Yeah, you can.
Sir, at the Zener point, when there is a slightly change in the voltage, there is a drastic change in the current. So how we can explain it with the energy that voltage slightly change in the voltage and a drastic change in the current, V into I into T. So there will be energy, lot of energy, but in a left one, when voltage is slightly less, then we get a current in a micros or something else. So how we can relate it with the energy? Can you explain, sir?
Okay, let's see. So you are saying that, let's say in this circuit itself, let's say we're having an external resistance here. Obviously, we are regulate this voltage with a Wiener diode because we want to use for a load, right? We want to use for a load. See, one statement to always remember. The thing is, if you the current in a circuit is totally depend upon what load you are using. Okay, the current will be decided by load. This RL will decide what current will flow. It's not that, yeah, you are saying that this is 2.4 volt. This is already touch the cutting voltage. Okay, reverse cutting voltage, reverse breakdown voltage of Zener diode, and this voltage is 2.4 volt. 2.4 volt. 2.4. This is 0. Okay. Now you are saying that here infinite amount of current is flowing. Your conceptual concept is that now here infinite amount of current is flowing, but that is not like that. In practical scenario, this current will completely controlled by this load RL. Okay, and also some current will flow here also. Okay, but in this direction will not flow of current will see by this Zener diode. Okay, only current will flow in this direction. Okay, so the amount of current is decided by this RL itself. So energy is conserved here. Okay, let's say it is 2.4 volt and we are making here is 1 ohm load is there, 1 kilo ohm load is there. Then what will be the current here? 2.4 by 1. 2.4 milliampere current will flow. Now, is it an infinite amount of current?
No, sir. But we are going to take energy through the RL.
Okay. We are utilizing the energy through RL.
Okay, sir. For the cutoff reason, the energy is greater than the reason beyond the cutoff. I mean, in the right direction of the x-axis. I mean, if the cutoff exists at a -5 voltage, and at the 4.9 volt is what will happen.
At the 4.
Yes, sir.
At the 4.9 voltage, that is.
No, sir, minus 4.9 voltage.
Yeah, reverse background voltage. We are actually connecting this voltage, connecting this diode at this configuration, right? This kind of configuration we are using. So here it is 4.9, right? Let's say, just we'll clear it up. Okay. After that we'll analyze. Let's say here the cutting voltage of this is 5 volt. Okay. Now we are standing at 4.9, and here is a load. Okay. Now this diode will not allow any voltage clip here, because this Zener diode will clip the voltage after 4.5. What it will do after after 5 volt, it will not allow the greater voltage here. Okay. So, but why do I need this? Because after 5 volt, if the rating of this load is 5 volt, after 5 volt, this if we allow this voltage to pass through the load resistance, then the load can damage. Okay, that's why you are not allowing the voltage to pass through the RL. But at 4.9 volt, okay, the voltage across here is 4.9 volt. Here the 4.9 volt, and at the 4.9 volt, the current will be decided by this load resistance RL itself. It is not that at 4.9 volt a very little amount of current is flowing. At 5 volt, the infinite amount of current is flowing. So energy will be very high here. You got my point?
Yes, sir.
Is your doubt is cleared or not?
Yes, sir, cleared, but there is some communication problem.
Yeah, so okay, if you are comfortable in any other language, you can say. If I know that, are you comfortable in Hindi or anything?
Yes, sir, I am comfortable in Hindi, but
you can say in Hindi.
So, sir, I am just asking, अगर ये जो ब्रेकडाउन रीजन में करंट इन्फिनाइट को टेंड कर जाता है, और उससे जस्ट पहले करंट बहुत ही कम होता है, तो अगर हम अकॉर्डिंग टू एनर्जी देखें तो एनर्जी के अकॉर्डिंग थोड़ा पीछे जाने पर हमें एनर्जी कम मिलेगी डायोड में, और उससे थोड़ा सा आगे जाने पर बहुत ज़्यादा। तो मतलब थ्रू द एनर्जी कंजर्वेशन लॉ, एनर्जी neither be created nor be destroyed. So how
Yes.
this happen?
Here the energy is not created, not destroyed. Okay, let's see at 4.9 volt. Forget about this. Okay, at 4.9 volt. This is RL.
Sir, but if in IV characteristic the current is tending to infinite after the breakdown voltage, it means it is behaving like a perfect conductor.
Yeah,
So
it's
we can say that there is no current flow between that, but it is conducting perfectly.
yeah.
I think that is what he didn't understand.
But the thing is that the energy will depends on voltage as well as current. Okay, and it's not like that the current, if yeah, it tends to infinity, but it's not like that. If there is a current there, it will change arbitrarily. It will completely depends on the what is the load that is used across that Zener diode. Okay, so you like your concept is this: just after 5 volt, at 5.1 volt the current will be infinity, but that is not the thing. That in practical scenario the current will not be infinity. So in practical scenario the energy is conserved because the voltage as well as current is varying slowly. And if the load is there, so what is the power here? I square R. Okay, and what energy? I square RT. What time add you are using, what amount of time you are using that RL, the energy will be consumed by I square RT. Now I is depend upon RL itself. This I square RL into T. This I is depend upon RL itself. This I is not independent. It will not become infinity at the time. It can. Okay, if you use that kind of load, it will, the current can be infinity. Okay, but that is not the thing. Is that always it will be infinity. So at any point of time the energy is conserved. This I square RT will be conserved. You got?
Okay, thank you, sir.
Hello.
Okay, thank you, sir. I got it now.
Okay.
Sir, for similar questions, where there's like a question with voltage is given, V1 is given, and reverse breakdown voltage is given, and like a voltage drop is given, will it always be that if the voltage is like higher, like 2 or 5 in this case, if the input voltage is higher than the breakdown voltage and the thing, will it always be that the V out will be equal to the breakdown voltage, or will there be any special cases, or will this be like the standard thing? What happens?
See, if the voltage can pass through that, like see, now I am using a practical circuit here. Okay. Let's say this is a light and this is a fan. Okay, it is not connected in series. Practically the fan and light are not connected in series in your home. Okay, but for the explanation purpose I have taken this. Okay, now this is your supply. Okay, and the rating given by this fan manufacturing company is let's say 50 volt. Okay, so he clearly mentioned in the data sheet that if you use more than 50 volt, okay, this fan can damage and you will not get warranty or guarantee, whatever. Okay, now say this voltage, whatever supply is coming to your home is 200 volt. Okay, now if you give 200 volt here directly, let's say the resistance here is very low. Okay, let's say both this having the resistance of 2 kilo, then what will be the voltage drop across the fan? 100, right? Hello.
Yes, sir.
Hello, Ankit.
Yes, sir.
Okay, so the voltage drop across the fan is 100 volt. Now the thing is, if you provide this 100 volt across the fan will immediately damage, right?
Yes, sir.
And you can't allow this thing will to happen. So what you will do, you will connect a Zener diode here, and you choose a Zener diode which have a cutting voltage of, let's say, 50 volt. Now whenever be the voltage cross above 50 volt, okay, this voltage will be kept at 50 volt. Now your fan is safe. That is how the Zener diode is acting as a regulator in practical scenario.
Okay, sir.
Okay, so now the thing is, your fan got saved and the voltage drop is also minimized here. Now if, let's say, in the same scenario there is not 200 volt is given, okay, let's say some 100 volt is provided to your home. Now is there any requirement of the Zener diode?
No, sir.
No requirement of Zener diode. Let's say we further reduced it. Let's say 70, not 70, 80 volt. So at maximum case, the voltage drop across here will be 40 volt. So this Zener diode will automatically always be in reverse biased, okay, and will not touch the breakdown voltage of the Zener diode also, because the Zener diode have a breakdown voltage rating of 50 volt. Now if you invest some money to buy a Zener diode and connect it like this kind of connection you make in your home, okay, so your money is completely waste. There is no use of Zener diode, right?
Yes, sir.
So the thing is, if you buying some Zener diode to create a circuit, so you have to first think that what is the situation here, if we need the Zener diode or not. In forward bias Zener diode is as good as a forward bias simple normal diode. So why we'll buy a fancy diode? And the reverse bias also, after some cutting voltage, it will giving you some advantages. So why will you buy it to invest some extra money? So if you are investing some extra money here, you have to analyze the situation and you have to think that is there any need of that voltage or not? Sorry, is there need of that Zener diode or not?
Yes, sir. I got it, sir.
Okay. Is there any doubt of anyone? Hello, am I audible?
Yes.
Is there any doubt? Okay then. So I'm ending the session then. Okay.
Sir, I have doubt in week 6 activity 16 question.
Activity 16%. Okay. So here only the 11 questions are there, right? Okay, then we'll also meet at the next week also. Then we'll discuss the 16th question.
Okay, sir.
Okay then. Then I'm ending.
Okay, thank you, sir.
Thank you
sir.
so much, sir.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.